Hey everyone, let's take a look at the second example in our method of difference. So as you can tell, right, we're going to do partial fractions again. In fact, many of your method of differences would have partial fractions. Therefore, you need to be kind of an expert at it, alright? So let's express 3r plus 8 in terms of partial fractions. So what you might do is basically do this, right? You'll list out the whole entire fractions and then write down the three fractions first. So basically there are three factors, right? Then you get a over r plus b over r plus 1 plus c over r plus 2. Then what you do is you then have 3r plus 8 equals to a r plus 1 r plus 2 plus b r plus 2 plus c r plus 1. Alright, now to solve for a, basically put r equals to 0. So you get 8 equals to 2a, a equals to 4. Then we have solving for b, so b, basically you put r equals to minus 1. You get 5 equals to minus 1 times b, get minus b, b equals to minus 5. Then you solve for c, which is basically r equals to minus 2. You get 2 on the left, you will get minus 2 times minus 1 times c to give us 2c, c equals to 1. Therefore, we have 4 over r minus 5 over r plus 1 plus 1 over r plus 2 to give us 3r plus 8 over r plus 1, r plus 2. Alright, now we've solved the summation. Okay, so we have n summation of 3r plus 8, r times r plus 1 times r plus 2, which we've already found in the partial fractions form. So let's just sub in the partial fractions form, which is 4 over r minus 5 over r plus 1 plus 1 over r plus 2. Now we just simply sub in the values, basically sub in the limits. So we start off with 4 over 1. Again, do not simplify, just leave it as its purest form. So we get 4 minus 5 over 2 plus 1 over 3. Continue substituting r equals to 2. We get 4 over 2 minus 5 over 3 plus 1 over 4. So far no cancellations yet, so let's just continue, right? 4 over 3 minus 5 over 4 plus 1 over 5. Then you realize, hey, 1 over 3 plus 4 over 3 minus 5 over 3 will give us 0. Then you cancel these three terms. Then what do you notice? You notice that you have to give at least the last two lines, right? Because even at the second last line, you get one term, right? So you need to expand until the second last line and the last line. So the second last line will be r equals to n minus 1. So you get 4 over n minus 1 minus 5 over n plus 1 over n plus 1 plus 4 over n minus 5 over n plus 1 plus 1 over n plus 2. Be careful of your limits at the end, alright? So there we have it. Now, these terms will be cancelled, so these terms will be cancelled, these terms will be cancelled, this term will be cancelled, this term will be cancelled. So you're left with 3 in the corner, top left hand corner, and 3 in the bottom right hand corner to give you, now you just simply simplify the equation. So 4 plus 4 over 2, which is give us 6 minus 2.5, so 6 minus 5 over 2 plus 1 over n plus 2 minus 4 over n plus 1. Alright, this would then give us 3.5 plus, well, you can choose to combine them to one fraction, or you can choose not to. So for me, I will choose not to, because sometimes they allow you to do so. Alright, but if they do want you to express in a single fraction, then go ahead. So with that we have it, 3.5 plus 1 over n plus 2 minus 4 over n plus 1. So this comes to my point where the method of difference need not necessarily be restricted to just two fractions, alright? Yeah, so it's also possible to give you up to 3 fractions, and then you can cancel across the three fractions. The thing to take note as well is that in the previous example, we only expanded to the last line. For this example, if you notice, when we're doing the method of difference, we need to include the second last line as well, because there's also one term that is not cancelled in the second last line. Therefore, we have to expand the second last line as well on top of the last line. Now, they want us to find now b, r equals to 2, 3r plus 5, and r squared minus 1. And they have the word hence with it. Alright. Now, what do you notice? You notice that r squared minus 1 is the same as r times r plus 1 times r minus 1, right? So let me write it down here. r squared minus 1 equals to r plus 1, r minus 1. And if you have r outside, you notice it's basically, hey, it's basically 1 less than the original function inside. Then you notice 3r plus 5 is also 1 less than a variable away from 3r plus 8, right? Because if you notice 3r plus 8 equals to 3r. Well, actually put it that way around. 3r plus 5 is basically 3r minus 1 plus 8. Alright, so you notice this function is basically 1 less than the function, the original function, right? So here you have fr, here you have fr minus 1. Because of that, we have to get back to fr, which means you have to increase this by 1. Because we increase the function by 1, we have to decrease the limit by 1. Alright, basically opposite of what we do to our function. So we get 3r plus 8 over r plus 1, r plus 2. Alright, you notice, if you look down here, if you increase it by 1, you get this r minus 1 becomes r, this r becomes r plus 1, this r plus 1 becomes r plus 2, which fits our original formula. And because we already have the general formula for our summation from r equals to 1 to n, and that in the final form we have r equals to 1 to b minus 1, we just need to sub in n equals to b minus 1. So you get 3.5 plus 1 over b plus 1 minus 4 over b. And there we have it, the summation of r equals to 2 to b of the function 3r plus 5 over r times r squared minus 1, which is basically fr minus 1. So there we have it, the second example for our method of difference.